All right, this is page 2 of the test review practice. An object weighing 15 newtons is lifted from the ground to a height of 0.22 meters. The increase in the gravitational potential energy is approximately. Gravitational potential energy is just mgh. The trick here is mg is already given. That's 15 newtons. They're giving you the weight, which is mg. So all you have to do is multiply by 0.22 meters. And you get 32 joules as your answer. Spring is attached to point A, 0.1 meters from equilibrium. So that would be your x. The same string is stretched to point B, which is 0.2 meters from equilibrium. How does the potential energy at B compared to A? Again, you look at the relationships here, which is the equation. Now, what you could do is figure out, with numbers, values for K and for the energy, or you can just realize that the energy is proportional to x squared. And what you're doing to x is you're going from 0.1 to 0.2, or you're doubling x. Because of the square term, your energy is going to be 4 times as great. As an object falls freely, the kinetic energy of the object. So kinetic energy, 1/2 mv squared. As it's falling, v is going up, so the kinetic energy is going to go up. Also, your PE is being converted into KE. A 3 kilogram block is initially at rest on a frictionless horizontal surface. There's a picture for it. The block is moved 8 meters, that's your distance, in 2 seconds. That's your time by the application of a 12 Newton horizontal force. So that's your force. Shown in the diagram below. What's the average power developed? Power is work over time, so force times distance over time. The force is 12 newtons. The distance is 8 meters, and the time is 2 seconds. So I believe the answer is 48 watts. Double check my math. The spring of a toy car is wound by pushing the car backward with an average force. So this is the average force. That's important, that average word, of 15 newtons through a distance of 0.5 meters. How much elastic potential energy is stored in the car's spring during this process? Some of you may have tried to do this, where you write out F equals kx and solve for what k is, and then plug that into potential energy is 1/2 kx squared. You do that, and I think you get 3.75 joules, which is wrong. And the reason why is this force here, if you put in 15 newtons, that doesn't correspond to the force when x is 0.5 meters. That force is the average force. So if we were going to graph that, when you'd be at this point, the average force, 15 here. When you get out to that point, you're really at a force of 30. Which means your K is equal to 60. You plug that in there, and you get 7.5 joules. There's an easier way to do it, though. If you just say that work is the transfer of potential energy, you can say it's the average force times the distance, which is 15 newtons, times 0.5 meters is 7.5 joules. That would be the easier way to do it. Next question, you have the weight of a boat. Requires a horizontal force of that much to move it across the water at that speed. The boat's engine must provide energy at the rate of. This you have to understand what you're actually solving for. The rate at which energy is transferred. Think about that. It's energy per time, but it's energy that's transferred, which the definition of the transfer of energy is work. So it's work per time is what they're looking for, which is just the power. Power is work over time. I know I just wrote that. Is force times distance over time, which is F times V. Remember the D over T is V. All these equations are in your reference table. So you have F and you have V. The weight is just extra information that you don't need. So if you multiply 600 newtons by 15 meters per second, I think you get 9,000 watts, which is answer 4. When you plug in there. Number 16, The work done accelerating an object along a frictionless horizontal surface is going to cause it to have a change in kinetic energy. It's just kind of a definition. Ball is thrown vertically upward. As the ball rises, its total energy doesn't change, especially if you neglect friction. PE and KE will be constant. So that's going to remain the same the entire time. Read it carefully. Don't be tricked. PE will go up, KE will go down, but the sum of the two will stay constant. And the last question, 0.5 kilogram ball dropped vertically from a height of 1 meter. So you have a ball that's dropped, bounces back to the height of 0.8 meters. How much mechanical energy is lost by the ball as it bounces? So you know how much potential energy it has, which is the only mechanical energy at the top. Remember, KE and PE is your mechanical energy. So you can calculate this. I don't know what the number is. I'll do it in a second. You also know that at this point it has mgh. If there wasn't any energy lost, these two numbers would be the same, but because they're obviously different heights, they aren't the same. So the difference in these two is how much energy was lost. When you do the math, I think you're going to get around like 0.98 joules. We round it up to 1 joule. Thanks for listening.